Well, thank you for having me. I'm always happy to be here, and it's an exciting kind of time to be in the Triangle, and I think it's an exciting time to kind of work in social networks and health. I think there's a lot of interest in it from kind of general population and other sources, and I think that with kind of new data coming online, there's a lot of new directions that can be pursued. One of the new directions that you can pursue, I think, is kind of collecting your own data, and that can be a really rewarding experience, but it also has a lot of challenges. So today I'm going to talk about a specific data collection method that kind of leverages social network connections in the population to recruit samples and to try and make generalizable inferences from them. And my main kind of point is that I think we can take it a little bit further and collect more network data within it that can really elaborate on kind of fundamental social network processes of which we're interested in. As a kind of outline, I wanted to talk through kind of the general intuition of the idea. The kind of prospect of sampling from social networks has long been a really kind of tantalizing prospect that we can make a lot of progress with. But unfortunately, over the years, it's kind of stalled, and it's only reinvigorated in the last maybe 10, 15 years as a kind of vibrant practice. So I'll kind of talk about some of the intuition of it, and then talk about why we would want to do it, how it actually is done, and then get into kind of the specifics of respondent-driven sampling ideas, including the concept of like hidden populations, where the method kind of comes from, and some of the key kind of elements of the method, including how it's applied, some of the concepts, some of the ways to determine whether it's been done well, and some things you might want to consider when planning it. To give an intuition, I think many people here have probably looked at things like this all week. We are interested in social networks. I think often we assume that there are kind of social networks that underlie the connections among people. And the idea of sampling from a network is that you could leverage these to recruit cases into your sample in a way that allows you to make inferences. So you might happen to know this person, and they would refer you to another person who would refer you to another person. They would refer you, and you could just keep getting referred as you kind of move through the network through this kind of series of referral-based patterns. And that's the essence behind the idea of respondent-driven sampling and other network sampling approaches, is this kind of referral-based sampling procedure. The key distinction between respondent-driven sampling and what's come before is really the distinction of certain restrictions that you put on who you can recruit and on ways that you kind of estimate from the data that you've collected to make inferences after you've collected it. Before I get into those specifics, though, I wanted to kind of set up a motivation for it. I think that these kind of approaches and new forms of data in general, they're really my passion. And I think that they're absolutely the future of social science research. This includes online data and stuff like that. But for purposes of today, I think kind of referral-based sampling and other things that change the way that we collect offline survey responses are going to be vitally important. There's lots of new groups out there that are incredibly interesting to study. In the recent years, there's been a rise in opioid overdoses in the United States, for instance. People who use opioids are very challenging to survey in general. And one of the more effective methods for surveying them is these kind of referral-based samples. Other groups of kind of policy interests, like undocumented migrants and things like that, are often very challenging to sample. So there's these kind of new groups that are difficult to sample, and new ways to be able to learn about them is important for social science to progress. Similarly, we have a lot of new theories and kind of tools, like theories about how connectivity affects health, tools about social network analysis and other kind of analytic tools that let us require us to use new forms of data, including on the connections that people have, and kind of trying to observe the connections rather than just kind of assuming that they're there. And last, I think that all surveys are facing a threat. And so new ways that we can reinvigorate kind of survey sampling in general is a vitally important topic. All surveys are facing hugely declining response rates and kind of issues with compliance. And I think that this is a real existential threat for the social sciences in general, who overwhelmingly rely on survey-based research. If we don't come up with new ways to get people to participate in surveys, it's not going to look great in 10 years for survey-based research. To kind of emphasize that last point, this is like one of the, I like this slide because it's like nice levity. I think this is one of the silliest things I've ever seen, was this headline touting the slowing of response rate declines in the last couple of years. They've sort of stabilized, whereas they were falling from 36%, look back 97 to 2012, they were crashing downwards. but they've really stabilized at like less than 10%, which I think is kind of, it's good. I guess it's not continuing to go down, but it's also a little bit of a challenge when 1 out of 10 people respond. I guess 1 out of 11 people responds to your survey on average. This can lead to all sorts of biases and other problems. Specific to responder-driven sampling and kind of connecting that first point about new groups that we're interested in sampling, one of the kind of core concepts is this idea of a hidden population, which are defined as people who don't have a sampling frame. There's no central list that you can go out and recruit them. They can be really difficult to recruit in general because there's no sampling frame, but there's other challenges too, like they don't want to participate in a survey because it's stigmatized behavior that they might engage in, or they don't trust survey practitioners because someone shows up and says, hi, I'd like to survey you. You might be a government official who's going to arrest them or deport them or something like that. And also just they tend to be kind of rare, so they can be difficult to find as well. Other kind of approaches to surveying hidden populations, there's a huge diversity of them in the literature. Other approaches are often kind of concentrated on reconstructing a sampling frame. So here's an example from Lilongwe. This is a slum area, and they wanted to conduct a sample of a slum in Lilongwe to better understand kind of malaria transmission and things like that. To do that, there's no central list of people in this slum in Lilongwe. There's no kind of population register or any of that kind of information. So what they did is they went and the researchers took a satellite image and they put dots on each of the rooftops under the kind of assumption that those are dwelling units, and we can kind of identify the rooftops as being kind of dwelling units and people live there. And then they sampled from those dots. They're hard to see, but you can see the darker dots here is the sample that they drew from the others. And they can then make kind of probabilistic inferences to the set of dots in here. And they've kind of like recovered the sampling frame through this kind of unique approach. But what responder-driven sampling is often interested in are situations that are even a little bit more complicated, where there is no dot, there are no roofs. There's nothing you can put dots on. There's no way to kind of reconstruct the sampling frame. And so you're sort of proceeding blind in the dark here and trying to recruit your sample and then make inferences about the general population from them. The kind of traditional approaches in that situation where you're working to survey opioid users or undocumented migrants or other groups, there's a number of ways that people have done it. One is just to take a convenience sample where you just recruit anyone you can find. You walk down the street, try and enroll people, things like that. Another kind of common approach that's very similar is the kind of clinic-based sample. If you're interested in people who inject drugs, for instance, you might sample people who go to a methadone clinic or who seek HIV treatment or a needle exchange or something like that. And so there's a lot of kind of clinic-based samples of people who are coming into offices, and you can kind of recruit them there. And the last is kind of like a location-based sampling approach, where you would say, we know that people who are, maybe you're interested in surveying homeless individuals. We know people who are homeless tend to congregate in these areas of the city, and so you'd kind of map out those areas and then sample those locations probabilistically. The problem with all of these approaches is that it tends to be challenging to know whether you're learning about people beyond the people who participated in the sample, beyond the like 200, say you sample 200 people who inject drugs from a clinic. Without any sort of probabilistic means of drawing them, you can't say that we know something about the set of people who inject drugs in this city. You can only really talk about your sample in terms of its composition and things like that, which really can be a problem for understanding the broader kind of composition, which I think much of social science is interested in. Other related issues is that sometimes the sampling frame might just be bad. Even in that Lilongwe example, perhaps the rooftops, most of them are unoccupied or something. Another issue is that often these kind of approaches are really time intensive. They tend to be rather costly to send out teams of researchers into all the places where homeless individuals congregate in a city or something like that. And in general, they tend to yield pretty small samples. One case that I'm familiar with is the PLACE method, which has been used to sample people who are at high risk of HIV in many parts of the world. And their samples on average tend to be about 150 individuals in them, which can be a challenge to make real inferences from them. So they tend to be costly and generally pretty small. Sort of into this kind of really a void stepped respondent-driven sampling, which was first proposed in 1997. And the core insights behind responder-driven sampling are the same as those intuitions before that I was trying to show, that you can move through a network where people refer other people. This is a rather obvious idea. But what responder-driven sampling did is it kind of took those things, put some statistical kind of assumptions behind how that process would unfold, which would allow people to make kind of inferences. And it took some kind of social leverage kind of components to make the sample go more quickly. And so it really kind of built in a lot of sociological insights into its fundamental operation that has been really effective for recruiting large samples. I just updated this today. Responder-driven sampling is a hugely popular method. You can see from the first paper in 1997, took them a few years to get anything else published, but in the last decade or so, this is like my normal work speed right here. It takes forever. But in the last couple years, it's really taken off in popularity. Numerous manuscripts have been published, 1232 to date. And over 540 studies have been funded by National Institute of Health, 540 plus kind of grant projects, with over $213 million of funding total. If it were a researcher, if responder-driven sampling were a researcher, it'd have an H-index of 59, which is pretty high. Means that 59 papers have been cited at least 59 times. So it's a hugely impactful method. I tried to compare it to kind of other network approaches. And I don't know what the best way to do this is, but I looked up egocentric networks in the NIH database. And RDS first started in 97, didn't really take off until kind of mid-2000s, versus egocentric has really been being funded from an NIH since 1990. They've only funded 254 egocentric studies. So just to kind of scale perception, I think it's helpful to keep in mind this is a big endeavor that lots of people are engaged in. It's been used for a huge range of kind of populations of interest, those kind of new populations that people are looking at, these different types of hidden populations. One of the most common groups is men who have sex with men. Other groups include people who inject drugs, commercial sex workers, other people at high risk of HIV. There's increasingly being used to recruit people who inject drugs and other kind of drug users, like those who take methamphetamines or opioids. But there's also kind of all sorts of novel applications too. There was a really nice study of wheelchair users, which I thought was really interesting. There's a dissertation student of mine did hers on vegetarians and vegans in Argentina, jazz musicians, non-institutionalized older adults living in the community. So there's all sorts of applications that this has been brought to, and I think there's lots of things that you could possibly do with your own research that you could apply this to. Most of the common questions that people ask about RDS have to do with originally a lot of it was, can we just collect data on these groups in general? That was kind of the first pass thing, which some of these groups, like jazz musicians, no one had ever really effectively collected a representative sample or a sample that you could draw inferences from. And then second, people often ask, what are the characteristics of this population? Usually in univariate terms. Overwhelmingly, the focus being in public health, a lot of the research is what proportion of the population has HIV, what proportion engages in HIV-reducing behaviors like using condoms, what proportion shares needles and things like that. And then there's a recent movement to include population size estimates in addition to this. So in addition to the composition of people, you might want to know how many sex workers are there in a particular city in sub-Saharan Africa versus another city, because that might determine your program planning and things like that. As I mentioned, RDS is overwhelmingly used in kind of the public health fields. These are the top 10 fields as the Web of Science tags RDS papers as being in. This is public health, occupational health, infectious diseases. This is substance abuse. This is kind of biomedical social sciences, immunology. As you can see, these are very heavily dominated by kind of the health fields. And these are the published papers, not the NIH-funded ones. So you can really see just from what has been published, it's really heavily health-focused. The core idea of RDS is sort of twofold. On the one hand, there's this kind of sampling component, and then on the other hand, there's this kind of weighting the data component that allows you to make inferences. And I think it's helpful to kind of distinguish them as separate entities. On the sampling part, RDS uses what's called this chain referral peer recruitment approach. This is exactly what I was showing in the beginning, where you kind of have someone refer someone else that they know into the study, and you proceed through that. What RDS does is a little bit different than kind of traditional snowball sampling, where traditional snowball sampling or snowball sampling that's employed in qualitative interviews and things like that, often you interview someone and you have them refer you to as many people as they can, and then you interview those people, and you keep kind of going without real system to how it's done. What RDS does, you take a group of kind of what they call seed participants that you might have access to through a clinic or some other way that you know them, and I'll talk about some of the things you should think of when trying to choose seeds in a bit. You give these seed participants 2 kind of coupons, and each person can only recruit other people with their coupons. And you ask them to distribute their coupons to people they know. And you can only participate in the study if you have a coupon, and you can you only give a limited number to people. So you're really kind of trying to systematize how many recruits each person can do, and you're trying to track the links that occur between people. Generally, you offer like an incentive both for your own participation and for recruiting someone else. There's kind of different ways that this is done. Maybe you're eligible for a follow-up interview if you've recruited someone, and then you incentivize that follow-up interview. But the idea is that if you recruit someone else into the study, you also you receive more compensation or incentive than you would if you didn't. Each person that then comes into the study, you continue to give this 2 coupons to and ask them to distribute to people they know. And you go until basically the sample size is obtained or sort of the coupons expire. You often put an expiry date on them. Sorry. I always get like ahead of myself talking. There's an assumption that nobody participates more than one time. This is not always, in the statistics part, this is not always assumed, but in practice, you don't want a situation where I recruit someone into the study and they recruit me and then I recruit them. In practice, that would be really problematic for your sample. You'd end up with 2 people and they would actually do quite well, but you would not. And the kind of core insight is that the researchers themselves are not really controlling the sampling process. Rather than walking up to someone and saying, "Hi, would you like to be in my study?" You're getting them to participate through kind of their peer networks and their friends that ask them to participate in the study. And this is really advantageous in a number of ways because it kind of reduces some of those stigma and kind of fear components. If I know someone, if my best friend tells me that they did a study and it wasn't a big deal and they didn't get deported and things like that, then I'm much more willing to participate. And I think some recent evidence is starting to bear out that response rates are substantially higher in these kind of peer referral surveys than they would be in kind of traditional samples of these populations. So that's sort of the actual operational data collection component. And then there's the stuff you do afterwards to kind of make inferences about the population in general. And that stuff, I generally call it like post-recruitment weighting of cases. The basic idea is to correct for theoretical aspects of the sampling process based on a series of assumptions that you've made. That if those assumptions are held and the corrections are correct, you can then make inferences to the population as a whole. And you can also quantify uncertainty. So RDS usually begins with these kind of initial seeds. Usually the recommendation is you pick like 7 to 10 members of the target population. This can vary from survey to survey, but a small number of people. And you try and select them based on, you want to pick people that are willing to participate. Getting more enthusiastic people early on is usually a good thing. And you want to pick people, the recommendation is to pick people with large personal networks. If your initial seed only knows one person and they ask who's in the population, and they ask that person to participate and that person says no, then they're done, right? But if they know 20 people in the population, then they can ask several people and you could actually maybe begin the referral process. And then lastly, the recommendation is that people are diverse on like what they call relevant attributes. This could be that maybe years injecting drugs if you're interested in people who inject drugs, or whether they've participated in a clinic or treatment or something like that. For other groups, it might be, in sex work, it might be like kind of the venue in which they work, whether they work in kind of high-end venues or street-based sex worker or something like that. But you generally try and pick kind of a diverse group of people with large networks. You give them the coupons, and then they proceed to recruit others into the survey. The coupons, usually recommendation is that you give 2 or 3 to respondents. It kind of varies. Sometimes people do more than this if sample recruitment is very slow. Sometimes people do less. People have tried 1, it usually doesn't work, so 2 is a pretty good kind of minimum number. And you only let people who are not seeds enter your survey if they've received a coupon from someone else who's already participated in the survey. The coupons are usually uniquely coded so that I can track whether, if I gave the coupon to you, whether you gave it to someone else. I don't have to see you give it to that person, but I can kind of track on the back end whether or not you did that. And there's some stuff that people have done with like non-physical coupons, but in general, they don't work very well. Like the kind of physical coupon passing seems to work much more effectively than giving someone like a code that they tell their friends and then they phone in or something like that. I have some stuff at the end about kind of web-based RDS and sort of the future directions around that. Typically, if you're designing coupons, you'd want to put your contact information. Usually you put like a kind of information about the study and some of the consent information on the back of the form. You usually want to put the valid dates so that people don't feel like when you end the study and leave that they like never got the chance to redeem their valid coupon and that somehow you rob them of money or something like that, right? Typically, you put like the interview site location where they actually can be surveyed. And then obviously, as I mentioned earlier, you put the tracking codes. So in this case, you'd put the interviewer ID and then whoever the initial person you gave it to, so that when the new person comes in with it, you can then link it back to the person that you gave it to previously. And when you've done that, when you've given out the coupons, say to those people at the top there that are seeds, and they've recruited some people that they know, and then those people recruited some people that they know, et cetera, you end up with kind of data that looks similar to this. You have people, you can see that person up there on the top left only didn't recruit anyone. That person next to them recruited 2 individuals who then recruited 2 each, et cetera, and this kind of really expanded as it went down. And then some of the cases, this one over here, they didn't recruit as many people and it kind of fizzled out a little bit more quickly than this group over here. But in the end, this is the sort of data that you get. And I think that this figure is nice. It's from DNAC people, including Giovanna Merli and Jake Fisher. I like this figure because it really highlights one of the kind of challenges with RDS that's really difficult to separate from whether this is how the network is structured or something about the sampling process that led to it. In this case, these are a sample of female sex workers in Luzhou, China. And the colors here represent what tier of sex work they work in. So the light blue is people who are in very high-end venues like karaoke bars and things like that. And then the kind of dark purple is people who are in kind of lower tier sex work, working in public parks or kind of street-based sex workers. And you can see here that it tends to be that the light blues recruit the light blues and the purples recruit the purples, et cetera. And there's kind of this kind of clustering of recruitment patterns. And one of the real challenges is separating out whether that clustering is because people recruit people who are similar to them or because they just know people who are similar to them. So I'll talk about that in a little bit. Another kind of example of RDS, just to kind of drive home that you are sampling from a broader network. This is a simulated sample that I did on this network. The black nodes are the cases that are sampled. I did a RDS style sample starting from right in here. And you can see that it tends to kind of gravitate towards like what I think we could think of as the center of the network. And that's a kind of common finding in RDS literature where you do simulated samples, that it kind of moves towards more central actors in the network. But there's large parts of the network that remain unexplored. For instance, all of this out here and all that out there. And the goal of RDS is to kind of be able to take the data that you recruited, these black nodes here, and make an inference about what the whole population, all of those cyan nodes, look like. I didn't want to make this too technical, but if anyone is really interested in running an RDS themselves or interested in analyzing RDS data, there's a lot of really great resources out there, including a very useful kind of website about with discussions about how to deal with different problems and things like that. There's lots of really good resources for RDS survey design. Lisa Johnston has a nice tutorial which has kind of questionnaires that you can use. It has sample consent forms, sample IRB applications, and things like that to kind of help you get up and running. It's really a vital resource. CDC and UNAIDS and other groups have similar kind of manuals. There's also kind of software for RDS analysis. One software package is called RDS Analyst, and this helps you kind of track the coupons and conduct analyses on the data. It's a standalone package. There's a nice R package, which has most of the newest kind of estimation procedures within it. And then there's some Stata packages that are a little bit more dated. There's also a lot of nice diagnostic kind of pre-planning stuff that you can do, including kind of formative research about how many individuals others know and things like that will help you decide whether it's a good idea and whether it's likely to work. Similarly with post-survey analysis to help with the same thing. So RDS makes a number of assumptions. Any kind of statistical or methodological approach kind of hinges on the assumptions that they make and how realistic they are, and whether they are upheld by like in practice when you're actually conducting the survey. The first assumption is this assumption that there is a social network linking members of the population. And that's not always guaranteed to be the case. There's lots of cases where, for instance, if you're interested in people who engage in sex work, maybe they only meet clients through online kind of fora, and they don't know any other people who engage in sex work. In that case, you might not be able to be referred by anyone to others in that population. But there's lots of cases where they do know others in the population. And so that's sort of the baseline thing you have to ask yourself. Is it likely that there is some network connecting members of this population? There are also a number of questions about the social network as a whole, that there is a network. Generally, there's other things that like the network is not too homophilous, it's pretty big, that the community structure is kind of got low modularity, that some things about kind of tie strength and reciprocation and things like that, that different estimators make assumptions about. And then there's assumptions that RDS makes about the actual sampling process too. So one is assumptions about the network that links people. The second is assumptions about how the sample is conducted on that network, including this idea that you're sampling with replacement. Some of the estimators make this assumption, but in practice, we know that that assumption is always violated because you don't let people participate more than once. Similarly, there are other assumptions that initial sample of seeds is unbiased. We know that assumption is often violated because you're taking a convenience sample of them. And so some of these things are more or less realistic, and different RDS estimators kind of rely on them to different degrees to make inferences. I'll come back to those concepts in a little bit. I wanted to talk about sort of the key concepts associated with RDS, including this idea that there's a primary interview as well as a secondary interview, the kind of respondent degree and popularity kind of measures that are often used to weight the cases, assumptions about random recruitment and bottlenecks that kind of really summarize a lot of these issues with assumptions about the network structure and assumptions about how people individually go about recruiting their peers. And then last, I'll talk about some of the kind of metrics of performance and some of the challenges associated with that. Different estimators make different assumptions here. So there's some nuance that I'm going to kind of gloss over, but in general, I think these are pretty good rules of thumb. I think RDS, it's helpful to think of both what occurs in the population, what you see as the researcher, and then sort of how the data is often presented at the end. So most RDS stuff, like that graph I showed of the sex workers in Luzhou, China, it's presented in this kind of series of chains that one person recruits two, right, in this kind of basic chain-based sampling procedure. But what actually happens in the population is actually a little bit more heterogeneous than that. And there's actually really interesting things of how the timing of recruitment can happen. For instance, this is what you actually see as a researcher. At time one, you sample person A, perhaps they're your seed. Time two, person B comes in for the sample. After they've recruited B, A will often come back to receive their secondary incentive for having done the recruitment. Then other people come in, people start coming back. And there's all this kind of staggering of timing of when people come into the sample. And I think in general, RDS has not done enough to leverage this kind of fact that you repeatedly observe individuals, and that you could ask people who come back in about what happened when they recruited this person, for instance. And there can be really nice diagnostics derived from this that you can use to kind of determine whether your sampling procedures worked. So the core factor in RDS is this kind of, in the statistical factors, is this notion of respondent degree or kind of popularity. It's typically, you ask people how many people they know who are members of the population. And what you usually use with this is you use the degree to weight the cases to correct for the likelihood of sampling more popular members. Like if you were to take a random group of people in a network and have them recruit one of their friends, the people who are recruited are overwhelmingly going to be, the likelihood of being recruited is overwhelmingly dependent on how popular you are, specifically how many incoming ties you have. But if we assume that ties are reciprocated, just kind of the number of ties you have in general. And this is a study that Jim and Giovanna and others did, where they recruited people through kind of simulated sampling, and they looked at how likely, how many times were they sampled. They repeatedly simulated the sample by their popularity. And you can see these lines are pretty straight, that the individuals who are sampled are overwhelmingly the more popular individuals. And this is kind of a basic feature of kind of network-based sampling in general, that each time you move through the network, you're kind of moving towards more popular people, which is why earlier on I suggested that often it kind of gravitates towards the center of networks. It's kind of degree centrality is a kind of measure of centrality. Centrality is very highly correlated with your popularity. And so often that's kind of the procedure. RDS weights many of the RDS weights are kind of some function of like inverse degree to kind of correct for this potential that you're giving more weight to the less popular people and less weight to the more popular people, because the more popular people are more likely to have been sampled through this recruitment-based procedure. Does that make sense? There's an RDS assumption that individuals recruit their peers at random. And I think that this is a source of great confusion in the literature, so I think it's helpful to kind of really think through what that means. The idea here is that if you're circles, you're equally likely to recruit each of your peers, not you're equally likely to recruit other circles and squares, right? If there's two types of people in the population, you can see here that 2/3 of the cases, if they were picking randomly among their ties, 2/3 of the time they would pick other circles, and only 1/3 of the time they would pick a square. So this is actually what RDS envisions should happen. If you have 3 ties, each of them has a 1/3 chance of being picked. What often happens in practice, and what people sometimes refer to as preferential recruitment, is that not only do you have more ties to circles, but each of those actually has a slightly higher probability of you picking them, in addition to the kind of overall compositional difference of the number of people that you know that are like that. And so this can lead to kind of estimation problems, because most of the estimators assume that the ties have equal likelihoods of being picked. But in reality, I might be more likely to pick people who are similar to me because I think that they're more likely to participate in the survey or other factors. So there's this preferential recruitment problem, and this can really cause havoc for a lot of RDS estimators. It's often talked about in a kind of way that can be confusing. It's not because people have more connections to people who are similar to them. It's not just homophily that drives this. It's actually like conditional on the number of ties that you have, like over and above homophily in the recruitment procedures. Some of these reasons might be that you have better relationships with similar people, or that a common one that you see in a lot of diagnostics for RDS surveys is that you want the person you know to get an HIV test, or you think that they would benefit from the incentive particularly, or you want friends who are doing riskier things to get tested, to participate in the survey, or maybe just the availability kind of issue, that it's not just the number of people you have, but also how easy it is to access them. Perhaps like your unemployed friends are more, they have more free time, they're more likely to participate. So there's all sorts of reasons that you could have this preferential recruitment over and above the kind of base structure, having this kind of over and above preferential recruitment that have to do with ways that could bias your sample. And many of these are not accounted for in traditional RDS estimators. Another concept that is pretty important in RDS is this concept of bottlenecks. RDS surveys typically argue that you shouldn't do it if you perceive that there are bottlenecks in the population. A good example might be that I worked on a project that was looking at people who inject drugs in the Ottawa region of Ontario. And Ottawa and Hull is a city in Quebec. It's kind of across the river, and they're really close to each other. But there's a lot of reasons, language, they're in different provinces, and they're even though they're really right next to each other, there's a lot of reasons that the network ties maybe don't cross between the places. And so in that case, you would want to do a sample in one side and a sample in the other, and not really try and cross both of them. And that's kind of the quintessential example of a bottleneck, of two groups that don't have that much interaction. And if you have a bottleneck scenario, it can lead to huge problems in your kind of inference. Here's an example with, this doesn't look like all that big of a bottleneck, but you can see that lots of people over here are white and lots of people over here are non-white. And with a sample of RDS size 500 people run on this kind of network, the variability of the sample from sample to sample is actually 150 times what you would get from the variability of a simple random sample, which is a real problem for kind of inference. Speaking of variability, I think it's helpful to quantify what the kind of different concepts are. RDS traditionally focused on this concept, or on this issue of bias, where it was really interested in like how accurate is the sample. And in this case, if this is the population parameter, say the proportion of the people in the network that are in the middle tier of sex work, which is what I was looking at in this study, in this case, this would be a biased sample. If you run 1 million samples of RDS, and this is the kind of frequency distribution of the mean estimates from those, you can see that this kind of the central mass of this distribution is substantially far away from the population parameters, so it's biased. A kind of related concept, but a little bit different, is this sampling variability. And this is sort of how wide the distribution of mean estimates are from sample to sample. So in this case, this is another time where I ran 1 million observations and plotted the distribution. You can see it's substantially wider than this one, which tends to be pretty narrow. And I think it's helpful to think of, there are ways that these two are going to trade off, and you might want a case where the sampling variability tends to be, or you might be willing to accept a little bit of bias in order to reduce sampling variability, and maybe this case here is like kind of just right, sort of like a Goldilocks sample. Often this is expressed in terms of root mean square error, which tries to capture both like how far on average things are, but also the kind of variability from sample to sample. One thing, the sampling variance, because I'm going to talk about this a little bit more, it's often expressed as design effects, which are the sampling variance that you would get from an RDS sample divided by the sampling variance you'd get from a simple random sample of the same size. So it's the ratio of sampling variances of RDS versus simple random sample. Simple random sample, it's a simple mathematical calculation. RDS, to date, there have been assumptions about it, but generally the sampling variance is obtained by like simulating it on kind of different networks, so you get a sense of what it might be. And generally, you can interpret design effects as a multiplier on the sample size. If RDS has a design effect of 5, for instance, that would mean you need 5 times as many cases to have the same inferential capacity that you would with a simple random sample. So if you had a RDS sample of 500 people, that has like the same statistical power as a simple random sample of 100 people if the design effect is 5. If it was 2, it would be like having a simple random sample of 250 people. Does that make sense? So I really wanted to kind of drive home this issue of both bias and sampling variance, because I think it's kind of a fundamental challenge for a lot of RDS studies. So to do this, I made a visualization where I took the Project 90 network, which is a network of high-risk heterosexuals in Colorado Springs in 1990. It's one of the few like hidden population networks where they actually made an effort to record all of the links among people in the population. And this is the network here. I showed it earlier with just cyan nodes, and here it's the red nodes are people who are white in this network, and the red nodes are people who are non-white, and the cyan nodes are people who are white. And so I'm going to try and estimate through repeated responder-driven samples what proportion of the network is non-white. So I did a responder-driven sample starting from 10 seeds with 3 coupons. I took cases without replacement, kind of according to the some of the operational practices of RDS, and I took a sample size of 150 people. For simple random sampling, I did the exact same thing, except it's not so simple because I took it without replacement, but it's still just a sample of 150 people selected randomly without replacement from the network. What I'm going to do is show the mean of each one, and I'm going to kind of stack them, just like you would if you were kind of building a histogram one sample at a time. So the first sample I took from RDS, the red lines here represent the true value, the true proportion that's non-white in the network, or the true proportion white in the network. And the first sample I did with RDS, it's like 79, 80%. The estimate is that 80% of people in the network are white. First one that I did, simple random sampling, is a little bit better, like 78%. Was the estimate right on track? But the key question is as you repeat sample after sample on the same population with the same kind of basic parameters, randomly picking people each time in the simple random sample and randomly picking the seeds and then letting the RDS proceed in the RDS sample, how does it kind of perform over time? And so this hopefully works. I'm always skeptical. So as I do it, I take sample after sample after sample, and each time I put kind of the number of samples that estimate at that value each case, and I'm going to do 500, I think, samples. And so there was one here that estimated 45%, one that estimated 99%. But you can see that the RDS sample, as time progresses, as you collect more and more samples from this, the RDS sample kind of converges around the population mean of about 78%, which is nice. It's kind of, on average, the samples are not very biased, right? The challenge, though, is that, and simple random sampling has a very similar kind of property, that on average, it's kind of converging around the population parameter of interest. The challenge, though, is that RDS is much more variable from sample to sample. And you can really see the width of this distribution substantially larger than the width of this distribution. And that's kind of the fundamental challenge. Its design effect is substantially larger than simple random sampling, which means that for any case, it's not like worth as much in statistical inference terms. I did it again with a larger sample size. This is sort of my backup slide, and it actually gets worse with a larger sample, the contrast, because simple random sampling also gains reductions in sampling variability from sample to sample as you increase sample size. So most of the early RDS work focused on that kind of bias thing, how far away from the parameter is the average. And only recently have people begun to really take into account sampling variability. That has kind of become a concern, but I think there's even a more fundamental concern than that, which is really quantifying the uncertainty. After you've collected the data, can you say how biased your sample is? And can you really put an estimate or a confidence interval around the sampling variability, so you know that if you were to repeat the sample millions of times in the population, it would kind of range, the estimates would range between a certain kind of level. The challenge for RDS is that this is not true. You generally have a large problem calculating the sampling variance or estimating what it might be on the basis of the data. Here's an example from Proceeding National Academy of Sciences in 2010 by Sharad Goel and Matt Salganik. And this is the Project 90 network here. And these are all, each of these points is one of the AdHealth networks, which is a large survey. And they estimated all the binary attributes in all of them using repeated respondent-driven samples from them. And they found the average design effect in the Project 90 is on the order of about 10, which is, means that for every 1,000 RDS cases, that's like having a simple random sample of 100 cases. And similar kind of results were obtained in the AdHealth networks, that design effects 5 to 10. So this is a really big problem. But even worse than that, you don't know from the data that you collect if that's likely to be the case or not. Here's an example from a paper that I worked on several years ago, where we were looking at trying to see whether RDS's procedures to estimate sampling variance on the basis of the data you collect, the confidence interval generating procedures, do they work? Do they accurately reflect the design effect that you would obtain? So here, as the sample size increases, it should be that the sampling variability or sampling variance goes down. As you get more cases, sampling variance goes down. This is the case with simple random sampling here. You can see it goes down very quickly. And then I took two kind of toy networks and simulated RDS samples on those. And on one of them, on B over here, you can see the sampling variability or sampling variance goes down very much more slowly than it does in simple random sampling. Whereas on the other one, network A, it goes down very, very quickly, kind of comparable to simple random sampling. And so what we want to know is, are we in the A situation or are we in the B situation? Is sampling variability going to decline more or less quickly? So I took the RDS sampling variance estimators that were in existence at the time, and I calculated what their estimate of the sampling variability would be. And I put circles for what it would be. And every single time, either with the results from A or with the results from B, it was giving me the estimate of the B case, or sorry, the A case, that kind of ideal kind of sampling variability. So the estimates were suggesting sampling variance was declining like this, like these circles, when in reality, at least for the B network, it was declining like this, which means that we were substantially underestimating the design effect for that network and giving far more certainty to the results than you would otherwise. And so this has kind of been a thorny issue in RDS for several years. until last year, people came up with some solutions that really improved that. And I think this is like why RDS is a really exciting topic right now, because there's all sorts of stuff that make it usable. That like problems get identified, but people are actually solving them, and it's rapidly becoming a much more viable enterprise. So similar to what I had before, these are the estimated estimated coverage rates, the extent to which the 95% confidence interval overlaps the parameter of interest, which in theory should be 95%. If your confidence interval, it's a measure of uncertainty, so it should overlap the parameter that you're interested in about 95% of the time if you're using a 95% confidence interval. These are all these different kind of attributes in the ad health network, whether you played tennis, did drama, if you had a health problem, et cetera. And these are kind of the estimators that people were working with up until about 2 years ago, similar to what I showed before. And you can see consistently where they should be at 95% coverage, they're about 50% coverage. So they're underestimating the variability by about half. And it can vary from attribute to attribute. Like some are really bad, some aren't so bad, and a little bit between the estimators. But this was sort of the state of the literature up until about last year. Newer research has proposed new estimates of sampling variability from RDS data, and these are the triangles here. They rely on a kind of tree bootstrap approach. And you can see that they're actually really right on target with that, right around the 95% confidence levels. So this is kind of exciting. Now we can take RDS data that we've collected and we can calculate the uncertainty underlying it and have a better sense of, are you in that A situation or the B situation, and have a better sense of what the actual results of the data suggest in terms of uncertainty, which I think is really exciting information. There are lots of estimators of RDS kind of sample means that allow you to kind of make inferences to what the population mean might be, what % of the population uses condoms or has HIV or other attributes of interest. They're kind of overviewed here. There's other ones that have come out recently that allow you to kind of reduce the assumptions about without replacement sampling, reduce assumptions about the size of the network or the amount of homophily or the directness of ties and things like that. And they're overviewed pretty well in some of those manuals that I suggested earlier. There are also a number of methods for estimating sampling variance. Most of these don't work very well, and the tree bootstrap one, that's the newer approach, works extraordinarily well, as I just showed on the last slide. As a general kind of comment, the estimator that seems to perform the best in a number of trials that I've done is this kind of linked ego networks estimator, where you take into account information about peers that you sampled in addition to the people that, you take into account information on peers that people who you sampled tell you about, in addition to the data on the people that you collected themselves. This can be really helpful for estimating things like known attributes in the population, but it's not going to be helpful for like hidden behaviors like condom use, where I don't know how many of my friends use condoms, for instance. But I do know how many of my friends have graduate degrees and things like that, or I can roughly estimate that. So it's very good for that sort of thing. Other estimators tend to work pretty well, are the successive sampling estimator, and even actually not adjusting the data works well in a lot of circumstances too. For estimating the sampling variability, that tree bootstrap estimator is the real kind of breakthrough in the literature of late. Other things you can do to help you kind of know more about your data after you've collected it. There's a wonderful paper by Lisa Johnston, Matt Salganik, and Krista Geil, and other people that came out a few years ago that proposed a number of diagnostics for RDS once you've collected the data. And many of these things are kind of simple things that you would think of, like you ask people, why did you recruit the people you did? And if a lot of people say, well, I wanted to give it to this person because I thought they needed an HIV test, and you're trying to estimate HIV, that's probably like a suggestion that might be a real challenge for you. You might have this kind of referral bias over and above who people know. You might also ask, how many people did you try and recruit, but they had already participated, which can be a real problem if the network is small, and that can suggest that you need to use one of the without replacement estimators rather than the with replacement estimators. And you can also do sort of things like assessing kind of bottlenecks and kind of seed dependence with kind of convergence plots. This is from their paper. This is the number of steps from the initial seed, and the population parameter, or the final estimate, is here. but you can see that some seeds seem to lead to, even as more and more cases go forward, it doesn't really change the kind of proportion of the estimates you get just from that seed versus other ones are up here. And it's helpful to think of like this idea that there might be a bottleneck in the population. If you see a consistent case where if this hadn't even moved back here, that they were really spread out, that there might be really distinct components that maybe each of the chains is tapping into. I have a few quick notes on web-based RDS. I think it's a really exciting area for future research, but I also think there are huge challenges for it. For people who are methodologically inclined, I think that the payoff of solving some of these challenges is enormous, but it's, I don't have any real good ideas for how to do it. Often in practice, what I've seen with web-based RDS surveys is that you typically need far more seeds, and you have to let it run for a lot longer because a lot of seeds tend to die out and don't end up recruiting anyone. So usually you'll see studies with like 30 to 60 seeds, which if 30 to 60 cases in a 300 case sample are recruited through convenience sampling, that is can be quite a big part of it and kind of a real problem. It's also very difficult to kind of verify that the people are eligible to participate in the survey just because they could just very well make up data. And it's also difficult to tell whether people are participating more than once. Like, you can put an IP address verification, but people can just switch computers. And then they can say that I recruited someone else and get both incentives. It can be quite a problem for things like this. It can be difficult to tell whether the respondent's a member of the population, et cetera. And also, there's always limitations with any internet-based sample, like people don't have access to the web and things like that. But I do think it's an area of great promise if you can solve some of these issues. My recommendations, if you encounter problems with RDS study that you're doing, is to kind of expand the recruitment. Usually it's you pay people more or you reduce the barriers to survey participation. Like you shorten the survey, you give them more coupons, you expand the number of seeds, and you kind of raise incentives. So these kind of issues typically will solve the problems, but not always. And at the end of the day, you might end up with just a convenience sample that you can't make huge inferences from. And because of that, I recommend that you lean on other features of the survey that you've designed. I have a study that the RDS component of it did not work, but we're still getting a few papers out of it because we had a lot of other interesting data that we collected within it, including on the ego networks of participants and things like that. RDS doesn't always look like it does on paper. It's like described in the literature one way, but often in practice you have to make adjustments like expanding the number of seeds midway through the survey or changing the number of coupons you give to people. And these can be kind of challenges for analysis. My final kind of recommendations, I really advocate strongly that you embed kind of additional social network data collection with your RDS studies. If you can get ego network data from people, at the end of the day, if your RDS component fails and you end up with just a convenient sample of seeds recruited through clinics or something like that, you still have really interesting network data that you can analyze. I also suggest that qualitative interviews are a good way to kind of bolster it. They can be helpful for both understanding maybe problems of what's occurring from a recruitment perspective, but also they can be helpful for kind of ending up with usable data at the end because often in kind of qualitative research, ego network research, the kind of statistical generalizability is not always the key point of them. So if you can embed them within your RDS study, you'll have a really valuable kind of study at the end. Often it's helpful to collect minimally identifying information about alters as well. For instance, in a series of studies I've done with other people, we've collected the last 4 digits of people's phone numbers and their gender and maybe the first letter of their last name or something like that. Not particularly identifiable information, but then I can know that these same 3 people in the network were all referring to the same person who didn't actually end up participating in the study. And that can lead to some kind of blended network inference that we can use to calculate kind of network structural components and things like that. I think that RDS is also very useful for like sociological applications. Overwhelmingly, it's been used in public health to estimate prevalence of HIV or condom use or things like that. But there's a lot of things that are sociologically fascinating questions that we can answer with RDS data that I think have not been applied as often, including questions about the network structure, including about multivariate relationships in the data, and things like that, that I think offer a lot of kind of potential. So if you remember one thing about RDS, it's that it has great properties. There's things about it that work really well. It's really exciting, and you can come up with unbiased, asymptotically unbiased estimates of population means and other kind of features. But you have to make a number of assumptions that are often a little bit unrealistic and kind of can be difficult to verify. The design effects are really high. So if you do a sample of 500 people, keep in mind that that is sort of like doing a simple random sample of 100 people. There's a real trade-off you have to make there. And even with these problems, I think that it gives us data on understudied populations that we don't know much about that are still valuable to learn a lot about. That it's an effective and quick method. Typically, RDS studies the average. There's a nice review out there that talks about how long they are and how many cases they recruited. And on average, they tend to recruit about 50 cases a week, at least according to that, which is pretty fast. If you've run your own survey, that's actually pretty fast. And that's sort of underselling it, because usually RDS studies take a while to get going, like 2 weeks, and you get maybe like 20 cases in 2 weeks. And then in the next 2 weeks, you get 150 cases or something. And so it's very quick kind of sampling recruitment method. And you can learn a lot about social networks from it. So thank you very much. Yeah. Oh, yeah.
Is there anything that you can do in the middle of sampling to determine if your sample is going in the wrong direction and try to prevent that from happening?
Yes, a little bit. So there's things you can do to determine it, and to prevent it from happening. It can be that can be harder. But to determine it, you can do things like those convergence plots as you're going. You can ask all sorts of questions about why did you recruit people and things like that, to kind of solve those problems. Say people say that they're recruiting other people because they thought they needed the money or something. You can kind of change the instructions that you give to people. In that case, you might consider lowering incentives, although that has its own kind of problems. But there's things you can do like that to kind of adjust on the fly. And that's why I think having kind of the diagnostic stuff built into the survey, as well as into qualitative kind of interviews with participants, could be really helpful ways to kind of determine what's going wrong early on. Often, too, you would do a lot of these things beforehand. You might do a pilot of 20 cases or something to determine, do you think it's going to work in this population? We need to adjust things and things like that. Okay.
So on your slide 25, can you tell us a bit more about why there are the C? They have like 2 primary interviews.
Yeah. So seed A has a primary interview where you first interview them, and then they come back in after they recruit person B here. So this is the second time they come in. And then they come back in here after they recruit person C. So I put it at time 5 because person C was recruited at time 4. So let's just assume that they come back in the next day. And they come in again there. So you actually end up interviewing them multiple times. Does that make sense?
So I'm wondering the number C. So C comes up at time 4 and time 8.
Time 8 should be C, and it should be Y. That's an error.
Okay. And so if this is the case, if we want to combine the whole like name generator in this kind of interview, does that, like based on your experience, do you think that would be better if we do that at their second interview because that there are more people there?
Yeah, see, I think secondary interviews are great for collecting kind of name generator stuff. Who did you think about recruiting is a good name generator you could do, and you can go through some of the attributes of those people, particularly people that they approached who then said that they don't want to do it, or that they already participate in things like that. There can be great things you can do to get kind of diagnostic results from that, and other network data as well. Next.
I have a question about if we need to expand the recruitment in the middle of our study, so it will cause bias in our analysis. Do you think solutions to how to correct those bias?
Yeah, so it really depends on the kind of estimators that you're using. Some of the estimators take into account, like the one by Crawford and stuff, just listed, take into account the number of coupons you gave and kind of the time that they're redeemed and things like that. And so it would cause problems for things like that. In general, people don't, when they do change the number of coupons that they give to people during the survey, or they bring in new seeds or things like that, they kind of gloss those points over and still estimate it without taking them into account. But you could also do things like estimating it based on cases recruited before that point and after, and making sure that there's not a significant difference or things like that. But in practice, there have not been a series of, I don't know what to call it, like principled ways to deal with how you retrofitted the survey in the field.
Awesome. This is great, Ashton. Thank you so much.